Уважаемые коллеги, разрешите начать сегодня заседание диссертационного совета. На повестке заседания только один вопрос. Это защита диссертации Зhanserik Nurlan по специальности D8D06 Computer Science на тему... Где тема? Я же тема где? На тему разработка исследования... А на английском нет? Разработка исследования алгоритма маршрутизации для беспроводной меш-сети. Это на русском языке и на английском. Это на английский язык. Development and research of a routing algorithm for wireless mesh network. Ну, сама диссертация написана сама диссертация защищается по 3 статьям, выпущенных в журналах серии Q1 и Q2. И диссертант должен предоставить нам полностью доказать или показать то, что было проделано. Значит, теперь по поводу присутствующих. Значит, по положению необходимо присутствие не менее 2/3 членов Совета для того, чтобы был кворум. При этом временные члены Совета должны в обязательном порядке присутствовать. Ну, сейчас это наблюдается, то есть на нашем Совете 8 членов Совета, из них 4 члена Совета это временные. Так, Раиса Кабиевна подошла? Подошла. Где она? Есть? Нет, Раиса Кабиевна. Просто я не вижу. Так, давайте просто еще раз проверим, чтобы не было проблем потом при посылке данного дела аттестационного. Значит, председатель диссертационного совета Атымтаева Лязат Бахытовна, это я, присутствует. Далее, постоянный член диссертационного совета Жаманов Азамат Марат, еще он едет, он немного припоздает, я думаю, отметится. Постоянный член диссертационного совета Кожахмед Канат присутствует онлайн. Канат Тимиргалиевич. Канат Тимиргалиевич присутствует. Канат Тимиргалиевич, вы здесь?
Я здесь.
Ага, все, Канат Тимиргалиевич есть. Значит, ученый-секретарь диссертационного совета Толемисова Гульфарида Иртаевна присутствует. Временные члены диссертационного совета Ускинбаева Раиска Кабиевна
Здесь
присутствует.
слышно?
Здравствуйте.
Здравствуйте.
Далее, временный член диссертационного совета Ожекенов Касымхан Адильбегович присутствует. Временный член диссертационного совета Шамаи Пакизар Сулгадиновна присутствует. Временный член диссертационного совета Молдамурат Хуралай тоже присутствует, да.
Здравствуйте.
Здравствуйте. Значит, кворум имеется. Все временные члены совета присутствуют. Можем начинать. Также требуется участие научных консультантов и официальных оппонентов. Научные консультанты Жукабаева Тамара Кокеновна присутствует. Да?
Здравствуйте. Да, я здесь.
Да, здесь. Очень приятно. И зарубежный научный консультант Мухаммед Утман. Are you here?
Yes, I'm here.
Uzman?
Thank you very much.
Okay, nice
I'm
to
online
meet you.
now. It's from Kuala Lumpur here. Yes,
Thank you.
It's quite far from Almaty. So I hope that the internet connection is always reliable, so that we will complete our session inshallah soon.
Okay. We hope to. Официальные оппоненты Сулиев Расим Ниязович присутствует.
Да, здравствуйте, я здесь.
Здравствуйте. Вы не могли бы камеру? Мгм. Здравствуйте, Расим Ниязович. И Атанов Сабржан Кубейсинович. Второй оппонент, второй рецензент, извиняюсь. Присутствует. Сабржан Кубейсинович. Ну, надо будет, наверное, как-то еще раз его предупредить, потому что это в обязательном.
Он был здесь, как бы. Сейчас я...
Был онлайн, да?
Здесь просто связь плохой.
Ну, вообще, здравствуйте, здравствуйте. Сабржан Кубейсинович, да? Очень приятно, мы вас видим. Пожалуйста, будьте во время сессии все время, поскольку это требование Совета, Комитета науки, чтобы рецензенты, члены Совета и другие члены диссертационного совета присутствовали во время всей сессии. Хорошо, значит, у нас кворум имеется и присутствие обеспечено. Теперь можем начать саму защиту. И прежде чем мы перейдем к защите, несколько слов о диссертанте Нурлане Зhanserik предоставляется ученому-секретарю Гульфариде Эртаевне.
Now a few words about the doctoral student Nurlan Zhanserik. Nurlan Zhanserik was born in 1985. This student's life began within the walls of our university in 2008. He entered the Faculty of Engineering and Natural Sciences with a degree in computer science and software. In 2012, he graduated our university. In 2016, he entered the master's programs, and then in 2018, he entered the doctoral program in the Eurasian National University named after Gumilev. All training was also in the field of computer science and software. Jobs were as follows. Ericsson Kazakhstan LLP as KCL project coordinator worked. National Information Technologies GSC, Electronic Engineer SSTO department. Bank Center Credit GSC, Business Analysts of Cost Analysis and Control Department, Financial Department. ZTA, Kazakhstan LLP, Technical Manager LTE, Technical Engineer Support Bimax. And Electromaster Ltd LLP, a Regional Manager for Astana. Company Hilti Kazakhstan LLP, Technical Consult Sales Manager. Next, NGO Capital Managers, Executive Director. Next, Astana IT University, Head of Laboratory Fab Lab, NC SCIK Industry 4.0. Next, Atyrau University of Oil and Gas named after Otibayev, Dean Faculty of Information Technology to the present day. Even being a sole trader, Ferradicin brand distribution, so co-founder and co-shareholder. Dr. Nurlan Zhanserik has a number of publications, total including 8. In journal from the list of publication 1, in a foreign publication based on the Web of Science Scopus 3, in the materials of a national conferences 3, including in the materials of foreign conferences 1. He has patents and implementation certificates for his work in the PayLink, Global LLP, Numax LLP, CAC, in the companies Happy Tech, Focus Trade, and Connected Home. He has established himself as a leader of many projects. For example, at KCL, he was responsible for coordinating the project, ensuring the interaction of the company's structural divisions, controlling business processing, planning, review, rental, installation, elimination of accidents, transmissions, optimization, power supply. That's all. Right. Ah. He has 8 publications. Ну, все сказано. Все уже сказано. Все сказано, да. 8.
Соответствует, да, по требованиям? Мгм. Хорошо. Тогда, наверное, мы можем предоставить слово нашему диссертанту. Вам дается 20 минут на презентацию и 20 минут на вопросы. Примерно. Рассчитывайте по такому времени. Пожалуйста, можете начать. You can start.
Алло. Hello, dear all. First of all, let me thank the Dissertation Council and the chairman of the Dissertation Council that they have accepted me. So in the end, I'm happily here
Чуть громче, пожалуйста.
to present my work, research work here in SDU University. As before informed, my name is Zhanserik. I'm a student as before informed, I'm a PhD student was at Eurasian National University. My supervisor is Tamara Kokerna, PhD associate professor at the same university, Eurasian National University. My foreign supervisor is Dr. Professor Muhammad Osman, University Putra, Malaysia. My research work on the dissertation topic is development and research of routing algorithm for wireless mesh network. The purpose of the research work is to develop a routing algorithm for wireless sensor mesh network in order to improve the viability of the sensor network. The subject of the research is a wireless sensor mesh network and a wireless mesh sensor network. In some cases, the objects of study are the characteristics of these nodes, controllers, including models in routing algorithm, energy efficiency on these algorithms, and the routing protocols for wireless sensor networks. The tasks are the analysis of existing methods and algorithms for routing wireless sensor mesh network. Second task is the development of models and study of the block diagrams, network topology, interconnection between these nodes providing energy efficient routing of information and data from environment and from sensors. Third one is to develop the model and study of the characteristics of heterogeneous wireless sensor networks. It's a case in related works. Fourth one is research and comparative analysis of the effectiveness of routing algorithms or protocols as LEACH, SEP, ZSEP. In addition, EasySEP is measured using various estimation schemes such as base station offset, field density variation, and variable node energy for comparison with these before named previous algorithms. The fifth one is algorithm development and software implementation of scan data, routing to the central microprocessor, development of a simulation system for wireless sensor network based on the simulator tests to show the effectiveness of the algorithm and its software implementation. This is the last 6 task. Of course, the scientific novelty is proposed was extended regional permanent election protocol has been studied as a 2-layer heterogeneous routing protocol based on hierarchical cluster. Second, modified method was provided for selecting the cluster leader as well as connecting nodes to the base station. Third one, here does nodes transmit data to base station in hybrid manner. Regular nodes, it means that regular nodes deliver records to the base station directly, while extended nodes use a clustering mechanism. This is aimed to extending the lifetime of the network, taking into account of course, the energy consumption of the whole network. Scientific novelties, other fourth one is proposed method increasing the stability of the network before the death of the first node, and also increasing the number of live nodes in the whole network. Fifth one, thus here, meaning that packet rate is increased, large number of environmental events are monitored, detected of, and in the end delivered to the base station or the sink. 6.1 simulation results show improvement in network performance in terms of parameters such as service life, number of packets sent to base station, and power consumption. In addition, the results obtained with the proposed algorithm are compared with different protocols. I'll explain them later. The proposed routing algorithms reduce the number of dead nodes by 2 times, increase the packet delivery rate, and reduce the performance, reduce the average power consumption up to 30%. Research content. Results of the study of the routing algorithms for a wireless sensor mesh network, as I described before. Structural diagram, network topology, interconnection of nodes, nodes providing energy efficient routing in information and processing these data from sensors to base stations. Algorithms and programs for routing scan data to the central microprocessor. Simulation graphic schemes of the efficiency of the algorithms and its software implementation. The relevance, the viability of wireless sensor networks nowadays, as IoT increase very highly, where this IoT implementation is used in smart city, smart environment, smart home. So these kind of networks should be well protected. Routing algorithms should be reliable to save the whole network lifetime. Because the disadvantage of such networks are the battery lifetime of this network in whole. So to improve and extend the lifetime of the wireless sensor network, scientists around the world are constantly developing various routing protocols that minimize and optimize the power consumption of the sensor networks nodes, where I propose my routing algorithm here. Systematic review. When the research work was started in this area in routing algorithms, I had to do a literature review on existing published articles, studies, papers. Most of them are from Scopus or Web of Science, so that when analyzing the works as K. Ashton or A.K. Gupta or Johari, I could make a taxonomic table where we can see classify routing algorithms researched during my research work, let's say. Design goals and systematic model. When designing the network, wireless sensor network, network can be classified or designed as a tree as a graph theory, so that the nodes can be defined like vertices, and the connection between nodes are classified as a edge, so that when the nodes are connected between each other, for example, from N5 to N6, where N is the node number, the connection is link connection is number 8. According to this connection type between nodes, where we suppose 8 nodes, connection between these 8 nodes, we can implement the connection between nodes in the matrix form, so that when mathematically eliminating this matrix, we can see that in the end, if the connection is established between two nodes, we can put there as 1. If there's no connection, we put there 0. So by eliminating this matrix, we get that we see which nodes are connected between each other, and how the routing path is established here. Proposed work. The proposed work is extended zonal stable election protocol for hierarchical wireless sensor networks with clustering mechanism. The schematic view of receiver and transceiver in these nodes can be shown as in this picture, the radio communication model, where Tx is a transmitter and Rx is a receiver, and of course the distance between them is the D. What is proposed? The threshold value was proposed here as a residual energy on the nodes after the first round, so that on the upcoming round, the cluster head could be selected according to the energy reduced or remained on the node. So this is the threshold value. If to explain the values here in the formula, the proposed formula is here, can be calculated here. E residual from initial energy which nodes have initially. Optimal number of clusters known formula in many research area. Proposed network architecture, we divide the network to 3 zones where normal nodes are deployed nearby the base station. We can see that base station is in the middle of the network. In zone 1, in zone 2, and zone 3, extended, or we can see advanced nodes are located. This is the flow chart where the nodes are selected. If they have lower energy, they cannot be selected as a cluster head in the upcoming, after the first round, or on the upcoming round. Simulation parameters can be shown like here. We imagine the network area 100 meter. We deploy the 100 nodes there. The initial value is 0.05 joules. Receiving, transmitting, data aggregation, and the other energies consumed are well known, or let's say during the literature review, it's the optimal parameters, where using these parameters we could get the suitable allocation of nodes here and the suitable power consumption when transmitting and receiving the data from the environment. Simple parameters in the field area, there are X and Y axis. Sync X-axis. Round max is the simulation result of 9,000 rounds. Cluster heads are supposed to be 4. So when we simulate the results, we can see that as shown in the graphic, the green line is a proposed EasySEP algorithm, where we can see that the stability period of before the death of the first node is much suitable, much more better than the previous or other protocols such as Leech, SEP, or ZSEP. So that on the 3000th round, the first node, on 2000th round, the first node is died. And we can see that the stability period is also higher than in other protocols. Of course, the packet delivery ratio to base station is much better. As we can see here, and power consumption of these nodes, or power consumption lifetime of the whole network, is twice 30% improved. Also, this proposed algorithm is compared in different scenario, like when we change the position of the base station. We imagine that the base station is not deployed in the center of the area, or it means that it's deployed at every place, at any place on the area. Even though proposed EasySep algorithm shows better results in simulation. Then we change the field density. It means that we use more nodes on the field area. Also, the performance of the proposed algorithm is better than others in comparison. And at the third scenario is increasing the initial value or initial energy on these nodes. Also, green line shows better performance. If to compare this compared algorithms, SEP, Leach, and ZSEP, EasySEP according to the network level, SEP is a heterogeneous network where nodes are normal and advanced or extended. Leach is a homogeneous where there are only normal nodes. ZSEP is heterogeneous as EasySEP. Network stability. In network stability, protocols like SEP and Leach show the lowest parameters. ZSEP and EasySEP show the highest in energy efficiency. As we can see, SEP is the lowest, Leach is the much higher, ZSEP medium, and EasySEP is the best in this energy efficiency, which is the key value when doing the research. Scalability, medium, very low, medium, and as we can see, ZSEP, it's not important value. In conclusions and results, the extended regional standing cluster head election protocol was studied as a two-layer heterogeneous hierarchical cluster-based routing protocol. Provide a modified method for selecting the cluster head, as I told before. Thus, nodes transfer data to different in a hybrid manner. Normal nodes directly, hybrid nodes through the cluster head. This method increases the lifetime of the network, stability in the network, and live nodes in the end are twice improved. Packet transmission is improved by 16%, and power consumption is for 34% is better than in other protocols. During research work, research results were performed on at the Science Committee of the Ministry of Education and Science of the Republic of Kazakhstan, grant number 1096531, where the grant is the development of intelligent information telecommunication system for municipal infrastructure, transport, environment, energy, and data analytics in the concept of smart city. Also was published 7 works, 5 of them are in Scopus database, 3 are in Q1 and Q2 database articles. Also, acts scientific works passed laboratory tests and implementation in Kazakhstan and abroad. 6 of them are taken, like if you count the Pay-Link in Malaysia, Connect Home in Astana, Happy Cake in Astana, Foxtrade, Numex, and CAC in Nur-Sultan. Bronze best paper award was taken during international conference on students and graduates and young scientists in Tomsk, Russia. And 2 copyrights were taken from intellectual property at the National Institute of Intellectual Property. These are the articles published in Q1 and Q2 and other published works, articles in conference, IEEE, in local journals, and most of them, of course, in foreign journals. And the research internship was done at the University of Malaysia for 3 months. If shortly go through the profile on Google Scholar, we can see that this quantity of citation is done on my works. This is in Scopus. This is in Web of Science. A total in Google Scholar 75 citations, in Scopus 43, in Web of Science 28, and Ash Index is of this type 4 and 3. These are the acts taken from private companies where I implemented my research work in practice. This is a patent, as I told before. This is the 3rd award certificate on the conference in Russia. Thank you.
Okay, that's all, yes?
Yeah.
Мгм. Ну, значит, диссертант завершил свою презентацию. Теперь время для вопросов. Пожалуйста, if you have any questions, you can ask him. Пожалуйста, Асылхан Адилбекович.
Саламатсыз ба? Мына жерде қазақша қоя берсем болады ғой,
иә қай тілде қойсаңыз сол тілде жауап беремін.
көріп отырмын, қарап отырмын да, мында енді менде бірнеше сұрақ туындап тұр. Біріншіден мында сіз бірнеше алгоритмді қарастырып отырсыз, содан кейін өзіңіздің алгоритміңізді разработка жасап, соны ұсынып отырсыз, иә? Вот бірінші сұрақ сол, по каким показателям вот лучше предлагаемый алгоритм от тех, которые вот вы рассматривали? Это первый вопрос. Енді екінші вопрос. Энергоэффективность сети была улучшена из вот процентный показательный цифра қанша? Сол қанша процентке улучшение? Соны көрсетсеңіз. Бізден көре алмай отырмын да сол. Әдетте енді көбіне біз цифрмен сөйлейміз ғой. Содан кейін осы екеуіне жауап беріңіз, содан кейін қалған сұрақтарды соны қойып жатырмын.
Рахмет сұрағыңызға. Бірінші сұрағыңызға келсек, по каким параметрам предлагаемый алгоритм маршрутизации лучше остальных в сравнении? В сравнении, жаңағы айтқандай, 3 алгоритм қарастырылған: Leach, SEP, ZSEP. Жаңағы алғашқы сетті алғашқы нода өлмес бұрын, яғни шамамен 3000-ші раундта, 2500-ші раундта біздің алгоритмде бірінші нода істен шыққан. Ал қалған алгоритмдерді қарасақ, кейбірі 1800, кейбірі 2000-ға жетпей, уже бірінші нода істен шыға бастаған, что приводит к дисбалансу в целом сети. Одан кейін, соответственно, дата, что собирается из окружения, высылается, база станцияға көбірек жіберіледі. Өйткені 4000-ші раунд өсіпсек, уақытпен өсіпсек, мысалы 4 сағат немесе 8 сағаттың арасында біраз уақытқа дейін ешқандай нода істен шықпаған. Яғни энергиясын сақтап тұра алған. Бұны жаңағындай 3-ші параметрді көрсетсек, мынандай әжептәуір 2 еседен көбірек басқа алгоритмдерге қарағанда энергиясы сақталып тұра алған сеть. Яғни 2 есе көп жұмыс істей алады. используя наш предлагаемый алгоритм маршрутизации. Бұл бірінші сұрақтың жауабы. Екінші сұрақ. Процентном соотношении 34%-ға көбірек энергия сақтай алған нодалар. Я где-то 3/1 деп алғанбыз. Жаңағыдай нодалар 2 есеге дейін былай айтқанда басқа алгоритмдерге қарағанда көбірек өмір сүрген. Саны, мысалы 100 ноданың 50-і былай айтқанда аман қалған. Яғни көп өмір сүрген, энергиясын жоғалтпаған. Сұрағыңызға жауап бердім деп ойлаймын.
Можно задать вопрос? Коллеги, слышно меня?
So there were two questions. The first was, what are the best indicators of your algorithm? And the second was how would you estimate the energy efficiency figures in your algorithms? And the answer was that we would underline the 3 algorithms that showed the best indicators. They were reach, SEP, and the third one.
Сіз ма мен
Zsep.
ZSEP.
Well, while others were dead before reaching the number of 2,000, like between 1,800 and 2,000, our algorithms continue to work, while the dead nodes probably caused the disbalance in the whole network. And we could say that they existed after the 4 round, between 4 and 8 hours, there were no nodes that were dead. And as for the energy efficiencies, we could say that there was an increase in 34% in energy efficiency that shows the double size of the viability of our nodes. Thank you.
Okay, other questions?
Zhanserik, can you please tell us how did you come to, or can you just describe your methodology? How did you find your problem statement?
Excuse me, last one?
Yeah.
Methodology and the
Yeah, methodology. How did you find your problem statement? Yeah.
problem statement.
Yeah, sure.
Thank you for your question. As I told before, during literature review, we could see many threshold values where the distance between the nodes is counted, where the hierarchical clusterizing was in other mode. So during this research, during this literature review, we could see that while selecting the cluster head in the cluster, the remaining energy on the node was not taken into consideration. So this is the case that the problem was established here. So we should take this threshold as a key criteria for selecting the cluster head. Thus, on the upcoming round, this cluster head with the lowest energy had no chance to be a cluster head. So that we can increase the lifetime in the whole network. Could I answer to your question?
Yeah, I think that, and also, could you please clarify that why exactly these 3 protocols you've been analyzing, Reach, SEP, and ZSEP, are they like the most famous protocols in viral sensor networks, or any other maybe variants were there, and you've been selecting these protocols to analyze them by specific criteria?
Thank you also for your question. Yes, these protocols were not taken randomly. Let's say, Leech is the most oldest protocol, or the first protocol, routing protocol in this kind of networks. It has around, if I'm not, if to be sure, around 4,000 or 6,000 citation on this paper. SEP is the second most famous protocol, which improved the Leech protocol, because Leech is a homogeneous network, where SEP is a heterogeneous, and this SEP also later improved SEP protocol by dividing the network in two different kinds. So proposed work was to improve the DSEP by taking into consideration, as I told before, other threshold value.
Okay, thank you. And also another question is regarding the efficiency. You say that you have like about 33% of saving of the efficiency, as far as I understand. And when efficiency was increased, I mean energy efficiency, did it affect to the security? Like, did you check it for the security purposes?
Thank you for your question. Of course, security was not taken as a research area, because maybe in the future research area can be taken into consideration, but at whole, no, security is not.
I mean, did you measure like any security parameters, or
No,
just only efficiency?
No, just the energy efficiency. The main idea was to increase the lifetime in the whole network by providing a better routing algorithm.
Okay, thank you.
Thank you.
Pakizar Sulgadyanova, please. Zhanserik, thank you very much for your presentation. I actually have 4 questions. Can I ask them one by one?
Yes, then I can answer by one, yeah?
Okay, yeah.
After first question.
Okay, great. So my question is about, I ask you to remember the period you started your PhD. So what was your initial research hypothesis, and whether you change it, shape it on the way, and along your PhD journey, did you identify some null hypotheses? So all research questions. Yeah, that's the first question.
Thank you for your question. If you could understand, before doing a PhD, yeah, before starting the PhD?
Yeah. I mean, when you started, when we start some research, we have some research hypotheses. But along the way, as we make some experiments, we can shape these hypotheses. We can change them. Yeah. Was your initial hypothesis changed?
During research?
Yes.
No,
Yes.
no. Thank you for your first question. Of course, while taking the topic for dissertation work, I had an experience in a wireless network in practice. So the routing algorithm really was a problematic one. Many research works, but sometimes they are not suitable, sometimes they are not good enough. So maybe as an engineer in the wireless network, I suppose that providing a better algorithm in a network, and also this mesh network or sensor network is also a new one in nowadays. And in the future, maybe it will be, I hope, used for other works.
So was your initial hypothesis is
No,
that extending EasySep protocol with hierarchical clustering will improve efficiency?
Yes, yes.
It's your
In the
initial
end, I
hypothesis,
could
right?
take this result.
Okay. Next question is, so optimizing channel and frequency resources in a mesh network involves a lot of calculations. And can you tell more about computational complexity of your algorithm? Did you measure that?
Which, sorry?
Computational complexity of the proposed algorithm.
Yes. In this work also, resource allocation in this type of network was estimated, so that the channel allocation or the frequency allocation we can research and get some results, better results, so that we count the number of established connection between nodes.
Okay.
So in the end, we can see that when these nodes are connected between each other, the full pass, routing pass as in F10 or F11 as an example, could pass through these nodes. Even one node is died or out of service, the whole network can be self-organized, or otherwise, if another node, new node is added to the network, also this network could organize itself. So will not affect the whole routing algorithm at all.
Okay, it's enough.
Thank
Thank
you.
you. Next question. How do you envision the practical application of the proposed extended EZ-SEP protocol in real-world wireless sensor network scenario? Are there any specific environments or industries where this protocol could be like beneficial, especially considering that you did not account like security matter? Maybe there are some it's not applicable everywhere, right? So
Okay.
what are the specific areas that it will be beneficial considering that? Yes.
Thank you for your question. Practical implementation of theoretical research work was to build, of course, in real this network, wireless sensor network, where as a microprocessor taken Arduino type of microcontrollers. So while building a network on using these microcontrollers, the network is established so that let's take this apartment, and where the workers enter if we want to see if the worker or your colleague came to your work, well, by using the cell phone or bracelet, Bluetooth device or Wi-Fi turned on device, when it enters the, let's say, the building or the office, this network, established network, could detect and see that the work came to this place and what time this colleague left.
Okay. You mentioned a lot of advantages of your algorithms, and can you mention at least one limitation?
Sorry?
Biggest limitation of
Limitation.
your algorithm? Yes,
Yes,
because
yes.
we heard a lot of advantages.
Yeah, of course.
The main limitation.
That's why the main disadvantage is the lifetime, because they are not supplied power energy. They have their own battery. So, of course, the purpose to take this research was prepare the routing algorithm, better one, so that while routing the data, the battery spent less energy. So the deployed network could survive for a long time.
And how do you handle interference, whether you take it into account?
Yes, interference occurs, of course, because cell phone radio frequency can
Overlapping.
interfere, can affect the network. But this criteria was not taken into consideration.
Okay.
Yes.
Thank you very much for answering my questions. I'm finished.
Okay, any other questions? Okay, I also have one question to you.
Коллеги, слышно меня?
Okay. Sorry, we just didn't see. Nurgul, please show us.
Кажется, меня не слышно, да?
Sorry, just we don't see your face. Мы не видим вас, Райскобян, но сейчас вас покажут, и вы сможете задать вопрос.
Ага, хорошо.
Чок-чок, свернул.
Райскобян, вы можете задавать свой вопрос.
Да-да, можно, да?
Мгм.
У меня вот следующий вопрос. Здесь вот Это, наверное, в новизне. Я бы хотела узнать, вот передача данных на базовую станцию гибридным образом. Говорит, что за метод гибридности и в чем его эффективность вот при использовании?
Спасибо за вопрос. Гибридный метод означает, что ноды расположены в сети разным способом, что обычно ноды с меньшей энергией находятся ближе к базе станции и передают данные напрямую к базе станции. А отдаленные ноды, образуя кластеризацию и выбирая главного нода как основной нод, передают данные сначала головному ноду в кластере, а этот головной нод потом сам отдельно передает к базе станции. Таким
Какие
образом,
параметры он улучшает этот?
Если бы отдаленные ноды также отсылали бы данные напрямую к базе станции, то в зависимости от дистанции между базой станцией и нодой, нода потратил бы слишком много энергии, и что привело бы к дисбалансу в сети, так как эта нода может быть сразу же выйти из строя. То есть не успев отправить данные, энергия была бы исчерпана, и она вышла бы из строя, то есть была бы неактивной.
А вот выбор метода кластеризации как делается? Вы это по расстоянию делаете это распознавание или каким образом?
Нет, вот как раз критерия для определения головного нода в виде в кластеризации происходит на основе остаточной энергии после первого раунда. То есть первый раунд — это тот случай, когда сеть развернута, данные были переданы, и в следующем круге при передаче данных, опять же, каждая нода вычисляет остаточную энергию, и у кого больше энергии, тот становится головным. Таким образом сохраняется себя, скажем.
Хорошо, спасибо. Ага.
So the question was, what was the method in selecting the nodes efficiency, and why do you think that the method of hybrid distribution is efficient? And the answer is that we have selected the hybrid manner and hybrid method of nodes because these nodes are close to the base station, while the extended nodes are closer to cluster, and thus they send the data to clusters first. If the nodes send the data directly to the base station, they can die before they can send the data fully. And there was also additional question: do you elect it by distance? How do you measure the nodes that should be set closer to clusters? The answer is that it's elected according to the indicators of energy remnants. So after the first round, the energy that remains in nodes is calculated, and those that are still energy efficient, they are elected for the upcoming round, second and third rounds.
Okay, thank you. Any other questions? Please, our online members, maybe you have questions. Okay. So also, I have one question to you. Your publications, your review for publications is about 2021. Now it's 2023. Did you have any review of new publications about your topic in this period?
Thank you for your question. You mean from my last publication to till now, did I review other papers published? Now, at the moment, I participate as a scientific researcher on a grant on security in these wireless sensor networks. So I also started the review, but in the other field in security. Of course, while doing a literature review paper, I had to read more than 200 and if I'm not wrong, 33 different papers, so that I could combine the advantages and disadvantages of these routing algorithms and could prepare this kind of review paper. Yes, I have started reviewing other articles now.
Okay, it means that you continue your research, yeah,
Yes, yes.
and working actively. It's okay.
During 2021 and 2023, one paper published, and at the moment one is ongoing.
Okay, thank you. So, any other questions? So you have? Okay.
Мен мына жерде бір қызық отырған тағы бір сұрақ болып тұр. Мында көріп отырмын, жұмыста акт внедрения енді, иә, жүзеге асыру сертификаттары келтіріпті. Соның ішінде осы жұмыстың енді қалай қай жерге енгізілгендігі туралы жазылғанда, атап айтқанда, осы мына көрсетілген микроконтроллерлерді, енді құрылғыларда IoT құрылғыларына негізделген сымсыз меш желісінің ұсынылған үлгісі жұмыс орнындағы қызметкерлердің қатысуын есепке алу процесін автоматтандырады дейді. Соның маған механизмін, жұмыс істеу механизмін кішкене түсіндіріп берсеңіз жақсы көреді. Қызық болып тұр да мына.
Рахмет. Енді жалпы өзім беспроводной сеть сымсыз желілерде инженерлік
Bluetooth арқылы жұмыс істеп тұр ғой онда қазір.
Иә, енді инженерлік опыт болғандықтан, жалпы өзім сол саланы жақсы көргендіктен, бірден тақырыпта да таңдау кішкене оңайға соқты деп айтайын. Одан кейін әрине результаттар шыққаннан кейін бұны жаңағы на базе каких желез немесе микроконтроллер возможно развернуть, да, такой сеть. Деген кезде жаңағындай егер детальға кіретін болсақ, Arduino тектес немесе Raspberry тектес қазіргі микропроцессорлар ғой, былайша айтқанда кішігірім. Солардан жаңағындай сеть құрдық, өзара байланыс құрылды. Жаңағындай сырттан келетін адамдарды білу үшін қосылған сеть как обнаруживать, жаңағы как работать деген кезде жаңағы келуші адам жаңағы сотовый телефонда Bluetooth-ын қосып қойып, мысалы кіруі мүмкін. Сол кезде сеть распознает, что есть вторжение емес енді, детекция. Немесе жаңағындай RFID браслеттер. Одан кейін Wi-Fi қосып қойып та, мысалы, кірген кезде происходит детекция, что человек или же сотрудник на месте дегендей. Немесе қай уақытта кетті, одан кейін сеттен қай уақыттан шығып кетті. Осы уақыттар фиксируется. Рахмет сізге де.
So the question is, can you explain the mechanisms of WCN in the area of microcontrols during the process of employment of employees? And the answer is that, yeah, the network that is set up can easily recognize the detection of the network interference by both employees and those newcomers who use the WSN.
So, and the last question, I think the last question, yeah?
So all the
Достаточно вопросов.
experimental results you demonstrated, they were based on the MATLAB simulation, right?
Most of them, thank you first of all for your question. Most of them was, yes, simulated on MATLAB platform.
Yeah, but I have heard of the act of implementation. Did you find any correspondence, like did the results from implementation in real world, like company, correspond to those of simulation results in MATLAB? Did you find the correspondence? I mean, whether results from the implementation prove the efficiency of the algorithm, or you did not measure?
Of
Just
course.
interesting.
Yeah, thank you for your question. Of course, while doing simulation, you have a better condition, yeah, no interference in laboratory conditions. in real life, of course, many factors affect the, let's say, the network. Yes, there were some problems in delivering the data, some delay, some lost, and sometimes the node is really died quickly. Yes, of course, there was a difference between laboratory type of simulation and the real-time deployment of the network. Oh, I didn't measure the exact value, but of course it differs a little bit. Thank you.
So thank you for your questions and answers. So I hope that it was the last. Raisa Kabirna, you wanted to ask something? Вы хотели спросить что-то, да? Нет?
Нет, я делаю предложение. Достаточно, наверное, вопросов.
Хорошо, все, спасибо. Я тоже так думаю. Okay, so we can finish the session of questions and answers, and now go to the reviews of our reviewers. And the first review is review of Rasim Niyazovich Suliyev. So you can do your review and say us.
Hello, dear commission members. So let me shortly give a feedback on the work of Zhanserik Nurlan. I have reviewed the works that he published and had a meeting with Zhanserik Nurlan where I had several questions that he answered to, and the topic itself is, as you see, as you know, is very hot nowadays, and energy efficiency is like in the top topics in the world, and Zhanserik Nurlan has prepared, has made a good research on that topic within a wireless sensor network, have proposed an algorithm that allows to save the energy, to decrease the energy consumption, and also make some efficient data transfer, improves the data transfer between the nodes and the base station. So in my opinion, this work deserves to be accepted, and its author to be awarded with a PhD degree. Thank you.
So do you have any questions, remarks, maybe comments?
Of course, there are future works, several, and we have discussed with Nurlan about that. That again, there was a questions today also that we were discussing with him about the security issues and the network interference about which he knows, and so there are challenges, and I hope that Zhanserik Nurlan will continue this research and improve it.
Okay, so now I should give the word to the our dissertant. Maybe if you want to say something about this collaborative work with your reviewer. So can you do something that he proposed to you or what you can say?
Yes, thank you. Of course, at the moment, about 1 month ago, started the research work on, as my reviewer said, on the security issues on this type of networks, and I hope I can get good results on this area, and can collaborate with many other researchers in this area, and try my best different area security issues.
So now the word word will be given to the second reviewer, Sabirjan Kubesinovich. So please give your review and remarks.
Добрый день, слушаю вас. Translate, please, in Russia.
Да, вы можете говорить на русском, на казахском.
Я так понимаю, вы просите зачитать мой отзыв, да, рецензию.
Да,
Если
пожалуйста,
все закончили
вашу
вопросы, или,
рецензию.
может, еще если у людей есть вопросы, наверное.
А вопрос можно задавать? Уже мы же.
Сабиржан Кубесинович, сейчас слово вам предоставляется по вашей рецензии. Пожалуйста, вы можете огласить там ваше мнение о работе и дать свои замечания, может быть, предложения.
Хорошо, да. Я так понял, что уже вопросы истекли, да? Хотя, мне кажется, еще не все вопросы задали. Итак, я получил работу. И я думаю, что эта работа очень интересная по двум причинам. Во-первых, она впервые проводит защиту по публикациям, а не по представлению диссертации. Это уже хорошо и большой плюс. Во-вторых, эта работа я уже знаком частично был, поскольку она выполняется в рамках Евразийского университета. Во-вторых. Ну и в-третьих, я позвольте немножко еще раз обозначу ключевые моменты из моего отзыва. Здесь их 10 страниц, поэтому позвольте, я не буду все полностью читать, я укажу ключевые моменты и процитирую в заключение, поскольку идет запись. Ну, сама технология, ячейская технология, mesh-технология, она сейчас каждым днем нарастает и становится все актуальнее. Особенно связано с интернет-технологиями, с учетом 5G, и поэтому вопросы передачи энергии очень нужны и актуальны. Особенно, когда в этой работе рассматривается новый подход, это гибридный подход, когда комбинируем не только прямую передачу от датчика к базовой станции, но и через промежуточные узлы, скажем так, через промежуточные группировки, так называемые кластеры. Здесь это подобный метод очень необычный, поскольку он позволяет в рамках кластера действительно, как вот заявил только что докторант, экономить до 30% энергии. То есть не передавать на всю мощность на базовую станцию, которая может находиться достаточно далеко, а делать в рамках небольшой группы кластера и выбирать там диспетчеры, которые передают информацию. Подобный метод очень интересный и был рассмотрен в различных работах, в том числе и, кстати, в стандартах ZigBee частично есть. Но автор, диссертант, скажем так, в своих публикациях подтвердил научную новизну своей предложенной идеи. Тем более публикации в квартале Q1, Q2, они, в общем-то, уже однозначно подтверждают, что есть в работе научная новизна и значимость. Я думаю, что теперь, если комиссия примет, поддержит это решение, то ему будет возможность доказать все это на практике, то есть выиграть гранты, практически реализовать, получить патенты и сделать, внедрить, коммерциализовать предложенные идеи. Я, позвольте, зачитаю свое решение для стандарта. Учитывая, что научно-исследовательская работа Зhanserika Нурлана по теме диссертации соответствует всем требованиям научной работы по специальности 6D070420 вычислительная техника и программное обеспечение и является полностью выполненной, считаю целесообразным присвоение Zhanseрику Нурлану, ученой степени доктора философии, PhD по специальности 6D070020, вычислительная техника и программное обеспечение. Я считаю работу нужной, актуальной и прошу комиссию, вернее, совет поддержать данную работу.
Это все, да? У вас замечания какие-то были по работе или в основном?
Замечания, да, есть, но они в основном чисто орфографического характера и большие технические замечания, которые, в общем-то говоря, можно было бы и не визуализировать. Ну, например, там скажем, в неявной форме там описана работа контроллеров, можно было бы реализовать ее и на плиз. Но это вопрос выбора исполнителя, докторанта. Также есть вопросы по, скажем, выбору виртуального лидера. Там составляется таблица энергозависимости. Ну, я думаю, это вопрос диссертанта, как он выбирает виртуального лидера в группе. Я думаю, что он вполне ответил на все эти вопросы в своих публикациях.
Хорошо, спасибо. Слово предоставляется диссертанту на ответы, предложения.
Спасибо. По поводу использованных терминологий, да, действительно есть много способов описания технологических, скажем, устройств. Это или же микроконтроллер, или же база станция, или же, опять же, как на английском, да, sync. И в период проведения обзора многих статей можно было бы все это заметить. И я использовал вот один из таких методов. И для будущего, наверное, да, учитывая замечания, приму все меры для улучшения. Спасибо.
Спасибо. Thank you. Перевод будет, да?
So, in my review, I would consider that this work is special because it's, first of all, based on publications in scientific journals. To my mind, data transfer is relevant today, and that's why the work is relevant too. So I would underline the hybrid approach that the candidate studied through clusters, which showed the indicator of the up to 30% energy efficiency by electing the nodes of cluster. I would also mention the scientific novelty that is approved because the publications were published in the journals of Q1 and Q2 degrees. So once it responds all requirements, I consider that the defense is successful and the candidate is assigned the degree of PhD holder. And the response of Zhanserik was that, yeah, thank you very much. I would appreciate that. There are many methods nowadays, like base station methods, as it is called in English, things. So I used one of these methods, and we came to the conclusion that it is effective and relevant. Thank you very much.
Okay, thank you. Сейчас слово предоставляется научным консультантам, непосредственному научному консультанту Жукабаевой Тамаре Кокеновне.
Hello everyone, can you hear me? Can you hear me? Меня слышно?
Yes, yeah,
Okay.
we can hear you.
Okay. So Zhanserik Nurlan PhD research work introduced a new heterogeneous routing protocol, well known as extended zip routing protocol. The result of study contribute not only to theoretical problems, but also to the solution of applied problems. And the most difficult task is develop and study routing algorithm for wireless mesh networks where energy efficiency is predominant. And the new model of the researcher in this direction and this area provides ample opportunity to study new issues in this field of science. and the research work contributes significantly to the solution of the relevant task posed in the research work. And he told before, based on the results of research work, 7 works were published, including 5 articles in the Scopus database. And the present PhD research work has a high level of independence because each is results of PhD students' publication, and their publication is high ranking in journals where the applicant is the first author. In general, the applicant has done extensive research in the field of wireless sensor networks, including mobile ad hoc networks, as well as the use effective mesh topology to these networks. To sum up, the results were presented and the interpretation is at high scientific level. It can be considered a predictive autonomous ruler with the ability to identify research problems, to approach them critically using relevant theory and methodology. The research in it describes is of the international standard, and I recommend the Zhanserik Nurlan to be awarded the PhD degree. And thank you for attention.
Okay, thank you. Thank you for your opinion. So, and now I invite our second supervisor, Dr. Sorry.
Yes, Assalamualaikum warahmatullahi wabarakatuh.
Yeah, Mohammed Othman, sorry, yeah.
Yeah, good evening. I think good afternoon. Evening, right? Okay, this one now here is 6:20 p.m. Okay, anyway, come to the works. I'm very happy about his work. Basically, he managed to publish 3 publications in high quality journals, which is Q1 and Q22, right? You know, HPSS, which is well known internationally. Come to publication, I'm very happy. Yeah, sure. Of course, there are a couple of conferences internationally in Russia as well as in Kuala Lumpur as well. That's kind of conference basically is a IEEE kind of standard, right? Come to the just now there is a question about the simulation versus test bed, as mentioned by the lady over there. There are 4 questions. And yeah, we admit that things is at the moment of time, because due to the issue of time and funding, so we are based on simulation instead of we try to compare the simulation versus the test bed base, right? It's good. Why not? If we have such infrastructure, then we can implement the real test bed, then compare the result with the real simulation. Of course, there are many issues of interference and so on. That's a common practice in real test bed. On top of that, there are a couple of, these days, the issue of big data, how the sensor can bring the big data, especially the to stream from one sensor to another sensor to a base station. So there is another big issue that we have to look after, right? That's the main challenge in the future. I'm sure that there will be, as you increase the number of sensors, then what happened to the routing, right? On top of that, we try to bring the idea of artificial intelligence. I'm sure that, Nurlan can bring the idea of artificial intelligence to the routing, trying to find the smart pathway in such a way that they can send to the base station. So that there are plenty of things research in the future can be done. For instance, let's say if the sensor is failed, suddenly it's failed, or a link failed, there are many things. So I'm sure that there are, on top of that, security, interference, and so on. I'm sure that this kind of research can be enlarged and open for the rest of the world. I'm sure that Nurlan should have aware what the latest development in this area. I'm sure there are many people in the world interested in this area. For instance, at the moment of time, if you check the Googles, the number of citation is about 30 plus. I'm sure that the number of citation will be increased by other researchers in the world. With that, I'm very happy about his work, and I'm agree that Nurlan deserves to be a PhD holder, right? PhD degree, right? Thank you very much, and thank you very much for Dr. Tamara as well. Thank you.
Thank you for your opinion. So now we just finishing the presentations of reviews of our research supervisors, and now I just ask other people, maybe you want to give a talk and some maybe your opinion about this work. So maybe Huralay Hanım, you want to say something about this work? Maybe you have some opinion.
Сәлеметсіздер ма?
Okay.
Мен даусым естіле ме? Нұрлан Жансерікұлы, сіздің алгоритміңіз бойынша жаңағы патент берілді ма? Бірінші сұрағым. Екінші сұрағым жаңағы беспроводный сеть деп тұрсыз ғой, сол бойынша жаңағы қандай принцип бойынша кластердегі лидер, диспетчер қалай анықтадыңыз? Жаңағы геометриялық өлшем бойынша ма, жоқ әлде басқару станциясы арқылы ма, әлде жаңағы арнайы лидер арқылы ма, электр қамтамасыз ету жүйесі арқылы ма? Практикалық тұрғыда қай жағына сүйене отырып іске асырдыңыз? Мен сұрағым естілді ме?
Рахмет сұрағыңызға.
Өте қызықты жұмысыңыз, әрине.
Екі патент алынған жұмыстарға. Екінші сұрағыңызға келетін болсақ, негізгі кластер хедтің таңдалу себебі жаңағындай ресерч жасаған кезде, көптеген ғылыми жұмыстарды оқыған кезде әртүрлі фактор бойынша таңдалған. Жаңағы кластер хед дистанция между базовыми станциями, дистанция между нодами деген сияқты көп критериялары бар. Жаңағы threshold value дейміз, критерий отбора кластер хеда. Менікі жаңағындай на базе остаточной энергии выбирается жаңағындай кластер хед.
Жақсы. Рахмет сізге.
So hello, I have two questions. First of all, do you have patents on this research area? And the second is, how do you estimate the leader in the clusters among the nodes? The answer is, yeah, we have gained 2 patents, so we are giving 2 patents in these algorithms. And as for the second question, so after long research, after studying lots of algorithms and seeing that different methods of distance between clusters and distance between nodes, we have focused on the method of the energy remnants in nodes after the first round. So we elect the nodes that have energy more than others.
Okay, thank you. Азамат Нурланович, может, вы скажете?
Yeah, I want to add about the dissertation, what I heard from the Nurlan Zhanserik and from the colleagues, from professors. I think that this is a really demanding topic, yeah, because the communication, like computer network communication, it just changed its direction to the wireless sensor networks, and we know that many fields are now using the wireless sensor networks due to that fact that the infrastructure is not everywhere gives ability to have cellular network and local area network and wireless local area networks. And we know different cases where the wireless sensor networks save lives of the people when the nodes can make their own connectivity autonomously, and especially with the power efficiency is one of the biggest issues, as far as I know, in the IoT, in the networking field. But that is why I think that this is a very demanding topic. Thank you.
Thank you. Maybe Pakizar.
I also want to give you my comment and appreciation on your work. I was able to see all the important things that we usually search in research papers, like scientific contribution, research contribution, something new that you develop, then research significance. What is the meaning of this research for the world? What will be the impact on the researchers, on the society, etc.? And you managed to communicate that well and managed to answer all the questions. And you also have not only theoretical contributions, but you also have patents and active implementations. So I think the work was done on a very high level. And thank you very much for your work. Good job.
Okay, thank you. Kasımхан Adilbekovich, maybe you want to know, to say something.
Мен енді өз пікірімді айтатын болсам, әрине мына ұсынып отырған алгоритмі мына энергия эффективность жағынан енді өте тиімді болып тұр. Әрине, және өзектілігі мұнда уже ешқандай күмән тудырмайды. Сондықтан енді мен де барлық қалған алдымыздағы жаңағы айтып кеткен пікірлерге бәріне қосыламын. Және де осы жұмысты қолдаймын.
Yeah, I would add, as many others already mentioned, the energy efficiency it's something special. So no doubt the work deserves its estimation. So I would fully support the candidate and his work.
Thank you. Раиса Кабировна, вы не хотите высказаться?
Я хотела бы сказать большое свое мнение. Работа очень интересная, она на стыке построена с использованием IT решений для телекоммуникаций. И вообще сам формат сейчас защиты, мы, наверное, в Казахстане это первые шаги, когда по такому формату защищается работы. В целом я поддерживаю работу, работа мне очень понравилась. По содержанию, как со стороны IT, я спрашивала данные, вникла. Я поддерживаю эту работу и думаю, что мы не ошибемся, поддержав нашего сегодня соискателя. Дальше будет работать. И я думаю, уже хорошие результаты будут по внедрению его работ. По-настоящему уже есть внедрение, но я думаю, что это послужит началу каких-то новых других работ и исследований. Поэтому я поддерживаю эту работу.
Спасибо. Канат Тимиргалиевич, вы здесь? Канат Тимиргалиевич отошел. So much for the active participation in this in our process. Перейду, наверное, как я сначала ввела. Значит, передаем. Сейчас следующий этап – это организация счетной комиссии. То есть сейчас мы приступаем к голосованию. И сейчас, наверное, предлагаю организовать счетную комиссию в следующем составе. Председатель счетной комиссии Азамат Маратович, члены комиссии Пакизар Сулгадзиновна и Касымхан Адильбекович. Не возражаете? Так, все остальных просим покинуть, да?
В онлайне тоже покинуть, да, нам?
Нет, онлайн, да, онлайн только остаются члены комиссии, временные и постоянные, и официальные рецензенты, а руководители не участвуют в этом процессе.
Я остаюсь же, да?
Okay, so now we should vote, and now just only the members of the committee will stay here. The consultants, the reviewers will not be included to this process. So please try, just I will ask you to, you can stay, but you will not in this process of voting. So just, you should know, okay? The voting will be online by using Google Forms now in the group. And for these members, it will be offline by using the special papers. Yeah, it's possible. Yeah. Но там надо будет собрать. У вас есть ящик? Хорошо. Окей. Да, но лучше, наверное, онлайн сразу всем, потому что тогда неудобно будет просто считать. Да, да. Давайте всем, значит, предложим Gmail. Мы же все Gmail дали вам, да? Вот сейчас. Да. Пожалуйста, ну, а может вы отдельно им скажете, что тогда не надо, чтобы они... Всем членам Диссовета, кроме консультантов. Уважаемые члены Совета, вам сейчас будет отправлена ссылка. Пожалуйста, по ссылке пройдите. Значит, ссылка в Google Forms. Там предлагается 3 варианта ответа. Нужно выбрать только один. Значит, первый вариант – это принять. Второй вариант – на повторную защиту. И третий вариант – это отклонить. То есть сейчас вы должны проголосовать, выбрать только один вариант. И после этого счетная комиссия предоставит результат. Уважаемые рецензенты, не забывайте, вы можете голосовать. Вы должны голосовать, да?
Осталось 2 человека, которые не проголосовали. Окей, остался один
Так,
человек.
это я. Сейчас, секундочку, я не знал, что мне тоже можно голосовать.
Ага, хорошо, ждем вас.
Сейчас, но у меня не Gmail почта, а такая почта, Mail.ru. Сейчас проверю почту.
В WhatsApp посмотрите, у вас ссылка должна быть.
Сейчас, момент. Все проголосовал.
Хорошо, у нас есть все 10 голосов. Ляззат Бахатовна, сейчас что, мы должны позвать докторанта? И так, только тогда озвучиваем. А вам говорить или... Публично. Окей, хорошо, я держу в секрете, никому не говорим, да. Мгм.
Слово предоставляется председателю счетной комиссии, который огласит результаты голосования.
Если есть еще профессора, то... Okay, dear ladies and gentlemen, thank you. Thank you very much for giving me this responsible job. As a result of the hidden vote, 100% of all voted person decided to award degree of doctoral of philosophy to Zhanserik Nurlan.
So, dear Nurlan, our congratulations. We recommend you to have this degree because also in committee of science they have the special commission. They will do some special extra work for that. So, but our recommendation is 100%. So, our congratulations. Thank you very much. Спасибо всем за ваше участие активное. Я думаю, что было хорошо. Слово предоставляется нашему докторанту, то есть диссертанту, да, для заключительного слова, если вы хотите что-то сказать.
Во-первых, всем спасибо всем членам Диссовета, председателю Диссовета, в лице вас, что приняли меня на этот совет. И в итоге мы смогли выступить. Как вы знаете, я являюсь выпускником этого университета по бакалавру. И была мечтой сделать еще один рывок и выступить опять же у себя на родных стенах, наверное, не знаю. И очень долго этого я ждал, мы все к этому готовились. Спасибо всем, что поддержали меня. Надеюсь, я стану вашим коллегой в ближайшее время. Рахмет. Всем рахмет.
Dear members of the council, dear chairman, I would like to thank you all for allowing me to defend my work here. As you know, I'm the graduate of this university in bachelor degree, so I'm glad to come back here and one more time in my alma mater defend my work now this time as status of a PhD holder. So hopefully I would become your colleague in a very nearest time. Thank you very much for supporting me. I really appreciate that.